Here is an explanation for the answer to final exam question number 26 in Electronics Demystified 2nd edition. If you have the printed book, please see the bottom of page 421. We're talking here about an audio signal that we feed to a loudspeaker. Presumably this output right here goes to a loudspeaker. We feed an 800 hertz signal to the input of this amplifier, get an 800 hertz signal at the output, and they're both sine waves. Well, the question only talks about what we're seeing at the speaker, but I'm going into a little more detail here because in order to control the volume, a good convenient way is to have a gain control like this. We can adjust the volume at will, so somebody's listening to the output at the speaker. We have this wonderful linear Class A audio amplifier courtesy of bipolar transistor. You can tell it's biased Class A because there are two resistors like this, a voltage divider going between the ground and the positive supply. You can usually tell in a bipolar transistor circuit that gives us Class A operation, which is what you're going to need in an audio circuit for linear operation with a single transistor. Anyway, what we do is we increase the volume by just enough so that someone who is not anticipating the change will hear it. Just the minimum amount in order to make that happen. How much is that in terms of decibels? And the correct answer is plus 3 dB. That means we increase the volume by 3 decibels. Decibel being a term defined in order to express the change that we get in the signal strength. So the correct choice in this question is choice C. Now you may have been tempted to choose A, plus 1 dB. That would be true, plus 1 dB. That would be correct if we were telling the person exactly when we would change the volume. So we would go 3, 2, 1, go. And then we'd adjust the volume just enough so that she could tell that there was a difference at the instant we said go. Well, that would be plus 1 decibel by definition. But because the listener is not anticipating the change, and that's a little bit of a trick in this question, the correct answer is plus 3 dB.